In our experiment, two human representations were used, a real human and a virtual human. We applied a within-subject design to examine differences. All targets were placed at the distance of 6 meters for consistency. The experiment consisted of 3 phases: warm-up, Task 1, and Task 2. In short, participants first adapted to the system, then performed a perception test, and finally a behavioral test. We collected both subjective ratings and objective movement data. After the warm-up, participants began Task 1. They stood 6 meters from either the real human or the virtual human. At the start of each trial, vision was briefly occluded while the target was placed. When vision returned, they quickly classified the target: up button for real human, down button for virtual human. Finally, they rated its realism and verbally estimated the distance to 1 decimal place. In Task 2, participants walked from a starting point to an end point, covering a distance of 12 meters. At the midpoint, participants naturally avoided either the real human or the virtual human while walking, and we recorded their trajectories using the MetaQuest 3 headset. First, the experimenter pressed the left-hand controller button to remove the occlusion. Then, based on the human representation they saw, participants pressed either the A button or the B button. Afterward, the participants completed a realism questionnaire. Finally, participants reported the human's distance allowed. In Task 1, each participant completed the same procedure for all human representations in random order, with each object repeated once, resulting in a total of 4 trials. In Task 2, participants walked straight toward either the virtual human or the real human, naturally avoided it, and then stopped at the endpoint. In the actual experiment, participants completed the same procedure for all human representations in random order. Each type appeared twice, making 4 trials per participant. Our results highlight several key effects. Human representation significantly impacted realism evaluation, completion time, and average speed. For the side of minimum distance, participants showed a stronger left-side bias when avoiding humans, especially real ones. For proxemics behavior, participants kept larger personal space buffers for the virtual human. Overall, these findings suggest that human representations influenced both perceived realism and avoidance behavior in outdoor mixed reality. Thanks for watching.